Now let's say you have the graph of an ellipse and you want to find its foci. In order to do that, you need to find the length of its major radius and its minor radius. So we have an ellipse centered at 6, 3, and coordinates at 11, 3. So it has a B, or a minor radius, of 5. And we have 6, 3 to 6, 16 gives us a major radius of 13. Okay. Now, it's key to know that the distance from the two foci to any point on this ellipse is the sum of the major axis, or 2 times the major radius, so 2a, which is 26. It's also key to know that the covertices, so 11, 3, is equidistant from both foci. So if I have a foci here, approximately, I know this distance is c. This is the length of the focus, distance from the center to the focus. I know this distance is the same as a, 13. And the reason for that is these have to make 2 congruent triangles in order for the distance from the two foci to the covertex to equal 2a. So if this is 13 and this is 5, I know this is also a right triangle. I can find the distance from the center to the foci. The equation is c squared plus 5 squared equals 13 squared, or c squared plus 25 equals 169, which gives us c squared of 144, and c is plus or minus 12. So now to find the coordinates, I just start out at the center, 6, 3. And again, because this is stretched along the vertical axis, I go up 12 and down 12. So 6, 3 plus 12 gives us coordinates of 6, 15. And 6, 3 minus 12 gives us coordinates of 6, negative 9. And that is how you find the coordinates of your foci of an ellipse given this graph.